All right, so if I'm doing the KC for this one, I'm going to be doing, or QC, it's the same. So like in the other examples that you're going to see, like if I say KC, the KC and the QC, or KP and QP, like those expressions are the same ratios. The numbers in them aren't the same, but they're the same ratios. So remember that this is like saying N2 plus H2 plus H2 plus H2, that 3 in the front, that's what that means. Going back and forth to an NH3 plus an NH3. And so if you're multiplying your products, it's like saying NH3 times NH3, which is NH3 squared. And then if you're multiplying your reactants, well, N2 is alone, but then it's kind of like saying H times H times H, so that's like saying H cubed. So that's where those numbers come from. But our shortcut, of course, is just to go with those coefficients and turn them into exponents, because that's what works quickly. So I'm going to go ahead and shift that over here onto this lighter color, if it will let me. It won't let me. Let me see if I can just copy it over there. There we go. So I've got some contrast there. All right, so that's our first one. Now let me look at the next one. It's the O2. So again, it's products over reactants. So QC or KC is going to be O3 squared over O2 cubed. And then on this one, it's going to take a little longer to write it all out because it's got so many parts. So I have CO3 to the 8th times H2O to the 10th over C4H10 squared times O2 to the 13th. And then KC equals QC, so that's going to be NH3 times, NH4 plus times OH minus, and then I'll put my NH3 in there. Now, these are all AQs, and this is a liquid, and we don't put liquids in, because that's a pure liquid, and so it wouldn't be any part of a mixture if it's a pure liquid.